And another question is, device cannot consume a, a big amount needs to consume field energy. And finally, network device support loss function. Okay, when you think about the IoT network, you need to think about these 4 points. There are more, but it's the main points. First, the network needs to support a large number of devices, many devices. Okay, things that the future, today and in the future more, you have in your home, for example, a lot of devices that can connect in the internet. For example, your refrigerator, air conditioner, lights, cafeteria, your smartwatch. For example, now in a house, for example, if you have 4 people inside the house, 4 adults, the 4 adults has at least one smartphone. Okay. But sometimes you have a computer, you have TVs, you have multiple smart TVs. In other words, you have a large number of devices. It's not true in the past. So it's a first requirement. The network needs support this large number of devices. The second one is device produce a large number of data. Sometimes the data is not big. For example, the data is only a string where you have attribute and value. For example, temperature 20 or humidity 20%. For example, sometimes the data that this device produces is a very short. It's a very small data. Okay, very small data and string data. Okay, very simplistic data. But the frequency is very high. For example, a device that monitoring, for example, the temperature in your home, sometimes need to send the data 1 to 2 times per second. Okay? For example, in the industry sector, the device in the industry IoT has a very high frequency. Sometimes the data is big. For example, the video all the times is big. Okay, and it's big, and the frequency or the period is very high. The period has a very high frequency. Okay, you need, for example, the video. If you have cameras installed in your home, you want to, for example, if when you are in the outside your home, you want to see what happens in your house. Okay, and all the time is high frequency. You have a high frequency, but sometimes you don't have this big data. Device need to consume few energy, or you cannot expand the device. Not a good approach. Device do not have a very high power consumption. Why? Because the battery need to be small. You need to use a very small batteries, and the concept is sometimes the battery the lifetime of the battery need to be very big. For example, a year, for example, in the device that you install in very remote place. Because the battery cannot support a very big power consumption, the network needs to be a little different. For example, the protocols need to be easy. The routing protocols need to be easy. The transmission protocol need to be easy. You cannot use a very advanced cryptography algorithm. And the consequence of it is the network most of the time don't actually ensure the connectivity. Sometimes your device is not connected, is in sleep mode. But when the device need to transmit, you need to find the network, need to connect the network, and need to transmit the data. It makes that the network is need to support this behavior. For example, internet, in the beginning of the internet is designed to survive for a nuclear destruction, okay? But the device all the time try to be connected. And if you destroy the one place, for example, the network need to find a different path. But if you lost one node, you lost one node. It's not you lost and find, lost and find, lost and find. No, you lost the node, okay? In the IoT, this behavior is not exactly the same, happening the same way. It's a little different. And the device, when you can have the situation, I lost the connection, I find the connection. I lost the connection, I find the connection. I lost the connection, I found the connection. It's a, I would say, it's a common behavior, okay? Did you understand this introduction to start to talk about this picture? Any questions? No questions?
Well, just one question. For example, in regarding uh, low power wide area, that will, is there any provider, for example, any supplier or provider that is only related to that kind of network?
Yes, today, it's the focus of today. Today we study technology. It's not exactly provider, but technology, no? You can have a multiple provider for this technology. But today we study technology that support these four features, okay? That you, the models operandis of this technology is to support, for example, lost connections, of low high battery life, low power consumptions, okay, low cost to device. The technology that we study today try to solve these four features, okay, and we study today, and we see. I believe I can answer your question today. Okay.
Ah, okay. Okay, great, great.
So this picture try to explain three different type of networks. Okay. The local area network, that is the network that you have in home. The lower power iterator, LP1, that is the network that has the focus of the focus of this network is IoT. And the last one is the cellular network, is the network like the 4G, 5G, the 4G, not the 5G. That is traditional network that you use most of the time to connect M2M device like the machine that you use to pay fees in the market when you use your credit card. Okay. And here you have the things that this network implement and the things that this network don't have. Okay. So the first thing is the local area network is short range communication. Okay, it's very short. It's 100 kilometers, but it's close. It corresponds around the 40% of the device that you use this network. So this network has well-established standards, okay, and you use inside the building. Why is important well-established standards? When you talk about the well-established standards, for example, Wi-Fi, you have, I don't know, maybe 10, 15 years that you have the standard that define the Wi-Fi. Oh, you suffer a lot of updates, but you keep the interoperability between the old protocols and to the new. For example, you can use the old device in the new network. Okay. The importance to have a well-established standard is because you have many providers. Is the question about the Wi-Fi? You can buy, for example, Wi-Fi from or a Wi-Fi NIC or a Wi-Fi interface from Google or from Intel or from Apple or from, I don't know, any company, and it's work if any router. It's very rare to have you buy an interface to use in a computer, and it's not working with a specific router, depending on how that is. Okay, it's why well-established standard is important. In the other way, in the other side, Wi-Fi consumes a lot of battery. You don't, for example, your laptop. Most of the time, your laptop, if you use Wi-Fi a lot, it works for, I don't know, 2 or 3 hours, no more than it. Your smartphone, independent which smartphone it is. If you use a lot, because, for example, now you don't use your smartphone, I don't use my smartphone, but if you use your smartphone all the time, the better life is around 4 or 5 hours, but it's fuel time. Okay. Another problem is the network cost independence. It's not cheap to have a network infrastructure to, for example, Wi-Fi. But in my house, I receive a router from the provider, and I use this router. Yes, but you use your device inside your home only close. What I try to say, you cannot use your Wi-Fi provider from your home in another home. You use only your home. Okay. For example, in the tech, I don't know where you are now, but if you are in the classroom, the physical classroom in the tech, you can see in the roof up, maybe at the end of the class, okay, you have a white device, and this white device is Wi-Fi access point. You have multiple, you have one device like that, maybe you have one for each 2 or 3 class to provide connectivity to all the campus. Okay, it's very expensive. You have, again, in this type of network, you have Bluetooth, Wi-Fi. Okay, if you use a low power wide area, LB1, this network is the network that is designed to IoT. Okay, the good things: low power consumption, low cost, and you don't have exactly problem with the position. Okay, it's the golden dream to IoT. Okay, low power consumption, low cost. Okay, you don't have problem to. It's not so expensive to create a big network, and position. It work. The device can move inside the network. But the problem: high data rate. You don't have high data rate. If you use this type of network, for example, LoRa, you can connect a very, for example, you can use LoRa to transmit video, but it's not so easy. Okay, And the another one is the imaging standard. What it means, you don't have a lot of providers, okay? For example, you have one provider that provide LoRa device. Maybe this device does not work well with the, give me a second. Okay. And this device does not work well with device from another provider. Okay, it's the problem of these standards. Finally, you have the cellular network. For example, the 4G, the 3G, GSM, and others. It's good because you have a very nice coverage. It's very rare you go to one place that you don't have a cell phone coverage. This type of network support high data rate, okay, video, news, voice communication, and others, but you don't have a lot of autonomy because you need to talk, for example, is to be possible to build this network, you need to connect with a cell phone provider like a Claro, AT&T, and others. And you need to follow the directions of this company. And the second is the total cost of ownership. It's a very expensive network. You pay a lot to use this network. Okay? Any questions till here, guys?
No.
Okay. So now we study different technologies that you can use to connect IoT. Some technologies like IEEE 802.11 is not designed or not developed to support IoT, but it's possible to use IoT in this type of technology. In particular, Wi-Fi is important because it's not so hard to understand. And I believe if you understood a little how the Wi-Fi works, you can understand the other type of network, okay? So, but we study all of them, okay? LoRa, WAN, NB-IoT, LTE, and others, okay, today. So the first, I have a video that tries to explain about the Wi-Fi, okay? Pay attention again, pay attention because Wi-Fi is a very important technology to understand the others, okay? So,
Hey, remember back in the day when your internet was connected through the phone line? Ugh, the sound of dial-up still haunts me in my sleep. Well, we've come a long way since then, and chances are that you're watching this video through Wi-Fi right now. So, how did we get here anyway? Just hop into my time machine and I'll show you. The roots of Wi-Fi go way back to the 1940s. That's when a popular Hollywood actress and inventor by the name of Hedy Lamarr came up with a way to prevent radio signals from being tampered with. That was a pretty important goal, since back then, radio-controlled torpedoes could easily be intercepted and change their course, which meant a huge fail for the Navy submarines. So she came up with the brilliant idea of frequency-hopping signals, where people who controlled them could jump from one frequency to the other and make those torpedoes practically immune to radio interference. Now, grab your double-knit blazer and let's fast forward to the 1980s. This is when personal computers had begun to enter our lives for good. But at that time, computers were connected to the internet through the infamous Ethernet cables. Seems to me like scientists were getting tired of tripping over all those cables since they decided they wanted to start sending data using radio signals. However, those early attempts were unsuccessful, since it all bounced back on walls, furniture, and pretty much anything that stood in a computer's way. What scientists didn't know at the time was that the problem had been solved a decade before PCs were even invented. It all started back in the 1970s with electrical engineer Dr. John O'Sullivan, also known as the father of Wi-Fi. At the time, he and his team were trying to detect radio signals from distant black holes in space, and they came up with complex equations called fast Fourier transforms. Unfortunately, they couldn't detect those black holes, and they put all their equipment back on the shelves to sit and collect dust. Surprisingly, 20 years later, Dr. O'Sullivan and his co-workers decided to give wireless networking a chance, and those forgotten complex equations would play a key role in the invention of Wi-Fi. After a lot of experimentation, they took their fancy fast Fourier transforms, added them in the mixture with the data equations they'd previously tried to send over radio, and thus they formed the basis for the Wi-Fi we all know and love today. But again, that was just the basis. Later, in 1996, they further developed their original key patent, and by 1997, they finally cracked the code and came up with the first version of the 802.11 protocol. Now, this is where you go, ooh, ah. Oh well, maybe you didn't catch what I was saying among all that numeric mumbo-jumbo. Okay, so let's talk about the name you're more familiar with, Wi-Fi. What does it mean anyway? I always thought it was some sort of acronym or abbreviation for two technical terms or something. But truth be told, and that's what we do here on Brightside, it doesn't stand for anything. Here's how the naming situation went down. Since their first protocol, the Wi-Fi Alliance wanted to come up with a catchier name than 802.11. Yeah, good idea. So they hired some market-savvy people to help them with that. And ta-da! Wi-Fi was born. Wi-Fi is a pun on the word hi-fi, which means high fidelity, a technical term used for high-quality audio technology. Now imagine walking into a cafe and asking the staff for the password to the IEEE 802.11. Haha. Anywho, now that we've covered all these decades and how we got to where we are today, let's take a look at how Wi-Fi really works. You already know that wireless internet helps you send and receive files, pictures, messages, and whatnot. But did you know that this is all via radio waves? Hey, don't forget about Hedy Lamarr and Dr. O'Sullivan. I told you all that stuff for a reason. Yeah, Wi-Fi uses radio waves to transmit data between your router, which is your Wi-Fi source, and your device, or the receiver. These frequencies are measured in gigahertz. To put all the sciencey stuff behind that in layman's terms, imagine this. You're sitting on the beach, enjoying the sun, and watching the waves crash on the shore. If you were to calculate the time between each wave crash, you'd be calculating the frequency of the wave. Let's assume that the time it takes for each wave to hit the shore is 1 second. That second is calculated by hertz. In other words, 1 hertz equals 1 second. Now, 1 gigahertz equals 1 billion waves per second. If you could see that many ocean waves moving so fast, then you might want to scoot out of there and head for the hills. So the frequencies Wi-Fi routers use are 2.4 or 5 gigahertz per second, which is why data gets transferred so quickly to your phone. When it comes to speed, the 5 gigahertz frequency sends information faster over shorter distances, whereas the 2.4 gigahertz router covers farther distances but goes slower. You also have to keep in mind the interference from other devices in our homes that also use the 2.4 gigahertz radio frequencies. For example, if you have baby monitors, garage doors, microwaves, cordless phones, and wireless cameras, they can interfere with your Wi-Fi. And this kind of interference can reduce the speed, or you might lose your internet connection altogether. Uh-oh. Hold off before you microwave some popcorn while binging on some Brightside videos. Although, the latter 5 GHz wireless frequency has 23 channels available to send all your information. Therefore, it doesn't let any of those home devices cause connectivity issues. When you turn your phone or computer on and get on the internet, all the information you'd like to access is broken down into binary code. You've probably heard of this computer language made up of zeros and ones. And when you access something through Wi-Fi, then that binary code is transformed into wave frequencies. If you're trying to visualize how this process works exactly, think of it this way. Imagine you're trying to send an embarrassing picture you took on your birthday to your best friend for a laugh. When you hit send, the photo is broken down into smaller pixels or packets and travels around different routers until it reaches your friend. Then these packets are quickly reassembled like a puzzle, and your friend can finally see the photo and giggle accordingly. All that happens with pretty much anything you try to send, be it videos, recordings, even my voice in the animation you're seeing right now. Whoa! Mind blown. Do you ever wonder what it would be like if we could see all these radio frequencies swirling around the room? I picture myself sitting comfortably on the couch, watching cat videos, getting work done of course, and suddenly all these waves become visible and I can see everything. I see the little packets of data going from my router to my phone, all those pixels and colorful frequencies drifting through the air. Everything would be traveling around me like a long exposure photo in slow motion, kind of like a little rainbow storm right in my living room. Now, I know what you're thinking. Okay, maybe I don't, but I can take a guess. If we're truly surrounded by all these radio waves, what does it do to our health? Is Wi-Fi dangerous? Well, the short answer is no. Wi-Fi works at extremely low voltages. Even at short distances, Wi-Fi is just part of the household smog that's generated by TV and radio signals. Wi-Fi uses non-iodizing wavelengths of radiation that are harmless to the human body. The sun, on the other hand, uses iodizing radiation wavelengths, or ultraviolet rays, that aren't so good for you. In fact, it's more dangerous for your body to go outside than it is if you just sit next to your Wi-Fi router. Great! I think I'll keep myself planted on the couch then. And to put your mind at ease a bit more, according to the World Health Organization, there is no scientific evidence to confirm that exposure to low levels of electromagnetic fields has any negative effects on our health. Okay, now that we've all calmed down and taken off our aluminum foil hats, let's talk about why your Wi-Fi signal drops in certain places around your house. Wi-Fi works just like light and sound. The further you are away from the router, the less energy you get. A typical router works at about 100 feet in every direction. As for what can block it, that's pretty much anything that conducts electricity, like metal, water, mirrors, and even our bodies, since they mainly consist of water. For example, if you stand between your router and your device, you might notice a signal drop. Sometimes, even thick brick walls and concrete can hinder the signal. You just probably won't notice the difference since it's teeny tiny. Another highly technical scientific measurement, just smaller than a tad. And there you have it, folks. Now you know a little more about the Wi-Fi you spend hours and hours on each day. Perhaps you'll appreciate it that much more, especially if you were around during the dark days of dial-up. I still thank my lucky stars each time I hop online within a fraction of a second. So, are you as addicted to Wi-Fi as I am? Let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But don't go anywhere just yet. We have over 2,000 cool videos for you to check out. All you have to do is pick the left or right video, click on it, and enjoy.
So, did you like this video? Did you understand what the guys talk? He's talk about a lot of things, but very in the superficial, no, not very deep. But what I think this video is nice because he explained about the foundations of the radio to understand how the Wi-Fi works. As we told, Wi-Fi works in the two frequencies, 2.4 and 5 gigahertz. The 2.4 gigahertz, you can go a little more far, and the 5 gigahertz, you can have more speed. And another important thing is you can have obstacles that you can decrease the power of the signal to go to the device. For example, some equipment that interference you use in the can produce a lot of noise, and your signal mix with this device, with this noise, and you can produce a lot of errors in the target device, like the doors, and the doors is a very big problem. If you live in the very old house, maybe you have problems like that. But one thing that this tutorial does not show is how the IoT, no, the Wi-Fi works. For example, you have a router. You told about the router, but does not explain. When you have a router in IoT, this router need to have an SSID. What is a SSID? Is a number or name that identify a specific network that this router is responsible. Okay. When your notebook or the tablet try to connect with this router, you use this SSID. Okay. Again, this SSID has an alias. Okay, like my home network, blah 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 network, tech network, but you have a MAC associated with this SSID. Okay, and this SSID most of the time is responsible to connect to work like a gateway that with you and your peers, or you and your that site, for example, the internet. But it has another type of service. One of these service is the DHCP. Okay, DHCP server. What is DHCP? Remember that you need to have an IP address to connect in the internet, or to use service in the internet. You need to use this address. But this address is a logical address. What it means? It means that, for example, it's not physical, it's not related to the place where you are. For example, you can have an address from tech in Brazil, for example. Okay? We use technology, virtual private network, but you can have this address from Brazil, the tech in Brazil or in any other place. It's a logical address. It's not related to the place where you are, but you have a physical address or a MAC address. Okay, the MAC address, this address here, the MAC, it corresponds to the physical device. Okay, the MAC address that you have here is your notebook address. Okay. The logical address, sometimes, for example, this SSID can provide a logical address, one IP, but when you stop to use this service, this device can delete the IP, delete the IP in the table. Okay, what it means? Okay, this IP1 is not more to the notebook mine. But you can reapply this same number, for example, to notebook 2. When notebook 2 stop to use these address, this SSID can share this address with another device. Logical address, but the MAC address is physical. You cannot change. You can change today, but in the beginning you cannot change this address. It's your address. Only you have this address. Where you go, for example, if you are here, this MAC address is, for example, MAC address A. If you are here, the MAC address continues to be A. But the IP address, you can have an IP address 1 here and IP address 2 here. Okay. Oops. So here in this example, okay, go ahead.
¿Sí le puedo preguntar en español?
Sí, claro.
No me quedó tan claro eso de la que sí es única y, o sea, que la IP sí pueden como haber varias y la que es única.
Vou tentar em English. I believe English is better too.
Sí, en inglés está bien.
Okay. So, you have 2 addresses, okay? In any network, okay? one address is the physical address. Okay, this address never change. It's yours. It's the address of your hardware. Okay, for example, I will show. Another one is the net address. Okay, it's the IP. Okay, the IP is a net address. It's logical. It can be changed. Okay, you can change. For example, I try to show it. Give me a second. Okay, can you see my terminal?
Yes.
Okay. When you type, for example, IP in Windows, you have one command that is ipconfig. Okay. When you type this command, ipconfig, you try to check the configuration of your physical interface. Okay. Here I have multiple interface, but here is the information about my Wi-Fi. Okay. If you see my Wi-Fi, you have give a second. I need to type another command. Okay, now I believe it shows everything. Okay. Here is my Wi-Fi. If you see here in my Wi-Fi, I have the physical address, okay, this one. And I have IPv4 address, this one, okay? You have two IPv6, okay? But don't worry about the IPv6 now. IPv6 has the same behavior than IPv4, okay? The physical address is the address that you have in your NIC, in your interface. Okay, it's again, now you can change, okay, but the idea, the original idea, it will never change. When the provider, the company, create your device and print this number physically, okay, in your NIC. For example, when you buy a NIC from Intel in the internet, for example, to use in your computer, okay, it's already has with one address, is the MAC address, okay? This address is set during the production of the NIC, okay? It's never changed in the time. It's your physical address, it's never changed. In other way, you have the IP address. The IP address is a logical address. You can change. For example, if you enter in the network from tech, you receive an address from tech. If I log in the router in your home, you receive a different address from your home. If you, for example, in the Mexico, you have public internet access. If you connect in the public internet access from the government, again, you have another complete different address, okay? It's the reason that you say, oh, the IP is a logical. Because why it's logical? Because it relates to the place where you are. And the physical address, the MAC address, the physical address is physical. Why? Because it's independent of the place where you are. Andres, did I answer your question?
Sí, muchas gracias, profe.
Okay. So in the network course that you study next year, you study in a very, very high details about what is a logical. You have a lot of exercise to, you study IP, you study MAC in detail, okay? But, okay, back to this slide. Here, each device has a MAC, okay? A physical address, okay? And when you are here, you have your specific MAC address, but receive an IP from the base, this router. When you move to another router, and here is another router, you can receive this another IP, okay? It's not good because fixing the situation, you are here in your place where you are now, and you move, for things that you are in the tech campus, okay, in Mexico City. You are in the, you start to talk with me using WhatsApp, and you have one IP, okay? But you start to walk in the campus, and for example, you move to the build 1 to the build 2, and you connect with another router in another access point. You receive a new IP. In particular about the WhatsApp, you lost the connection for a time, okay? It's a bad situation. If you think about the cell phone technology, it's the same idea, okay? This behavior of Wi-Fi is the same. In the cell phone technology, you have a different access point, and you connect one access point to other. Is this? There is a technology that is the name is handover, okay? And what it means handover? The handover, you have handover to avoid the situation that you are connected with the access point, move to another access point, and drop the connection. The handover is to have this type of situation, the extended service set. Again, it's not only to Wi-Fi. You have the same functionality, the same feature in the cellular network. What means handover? Handover is you are here with an IP from this access point 1, okay? You have the IP 1, but access point 1 and access point 2 is from the same company. For example, is from tech, okay? Access point 1 is the tech, and access point 2 is the tech, okay? Or access point 1 is from Claro, and access point 2 is the Claro 2, okay? Or access point 1 is from AT&T, and access point 2 is from AT&T. You are in the same big network, but you use different access points. The handover is when you start to move to the close to the end of the range of the access point 1, okay, here in the blue lines, okay? Access point 1, identify that you close to the border of the access point 1 range, and start to talk with the access point 2 and say, oh, access point 2, I have a user, notebook mine, that is close to the end of my service. I move this user to you, okay, access point 2, and access point 2 say, oh, yes, but I didn't see this guy yet. Okay, no problem, you'll see. When the notebook mine start to be seen here, and sometimes it's not like that, okay? Sometimes the coverage here, okay, this access point 2 have more coverage, and you have a common place that all the two nodes, the two access points has coverage, okay? When the notebook mine is here, the access point 2 say to access point 1, oh, I found my notebook mine. I can assume now. And you move the connection to the access point 2, and you don't change the address. You keep the same address. And you don't have interruption between when you move to one access point to other. Did you understand this idea? The name of this feature is handover. Did you understand it?
Yes.
Okay. This feature exists in any type of wireless technology, okay? Wi-Fi, 4G, 5G. What changed is the efficiency of these models, okay? Go ahead, Cristóbal. Do you have a question?
No, it's okay. I understand.
Okay, guys. So okay, stop here. Stop share. I give a 10-minute break. We return 10:30. Okay.